In this video, we're going to do the opposite of eliminating the parameter. In fact, we're going to take non-parametric functions and do what's called parameterize them. In other words, rewrite them as parametric functions. Basically, our process to do that is to pick one of our variables and just choose some expression in terms of t. So it could just be t, could be 1 plus t, could be 1 minus t squared, anything you feel like. And we're going to use that to parameterize our function by plugging it in for the other variable. So let's go ahead and try out this function here, y equals 1 minus x squared, and we're going to do two different parameterizations. If you remember back at the beginning of the section, we were talking about the path of that baseball. We had two different parametric functions that traced the same curve, so let's come up with two of our own. In part A, we're going to use the parameterization where t equals x. Okay, so in other words, if I'm going to use this equation, instead of writing x, I'm going to replace what that is in terms of t. Well, x is t. So instead of x, I'm going to write t. So this comes out to y equals 1 minus t squared. And I already decided x equals t. So there it is. That's one parameterization. In part B, they wanted me to do it differently. They said let t equal 1 minus x. Okay, well if t equals 1 minus x, then let's solve that for x. So I'll add x to both sides. I'll subtract t from both sides. That means x equals 1 minus t. So let's plug that into this equation. 1 minus x squared, well x is 1 minus t. It's 1 minus, I need to FOIL this out, 1 minus 2t plus t squared. And if I distribute that negative sign, I've got 2t minus t squared. Okay, so my parameterization here is that x equals 1 minus t, and y equals 2t minus t squared. So these two parameterizations are going to trace the same curve, it's this parabola here, but they're going to trace it in different ways. I want to go ahead and look at what that tracing looks like. If you look in the lecture notes, you can actually see a link that I've put in there that lets us get this. So give me just a second to pull that up. So I've got these both pulled up here. There's my first one, there's my second one. Let me turn off the second one for now. Watch what happens with this first one in red. Moving from the left side to the right side. Alright, let's turn that off really quick. Let's look at the second one. This time I'm moving from the right side to the left side. And let's see what they both look like together, if they're both turned on. They're going in opposite directions, and maybe even at different speeds, kind of hard to tell, but they're moving in opposite directions. Turns out there's lots of different parameterizations I could have come up with. Just pick any expression you want for one of the variables in terms of t, and unless it just breaks, that's going to give you a parameterization. So often if you need to parameterize something, just pick the easiest thing possible, like let x equals t. That tends to be the easiest thing, but if we're told to use a specific parameterization like in these problems, we can do that too.